Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. So, moving on, let's talk about basic router configuration. So let's consider this type of topology. We have 2 routers and we have an ISP, a third router, off of router 2. So here we have a IPv4 and IPv6 network. So we need to have R1 understand that the default route to go to the internet is to send to R2. So if we're looking at the configuration, we have the basic host name, password, synchronization, securing SSH and whatnot. We have a banner. We have the appropriate IPv6 address information configured. We have the interfaces turned on and saved. But you'll notice we don't have a lot of route information. This literally is just basic addressing and no route information. So in order to configure the router, we have to actually have route information so communication can flow. If we look at a basic switch and a router configuration, command structure is the same. A router will have addresses typically where a switch will not. I understand that switches has SVIs and that might have an address and whatnot, but the rest of the commands are pretty similar. But a router should have route commands explaining how to forward the appropriate information, and this does not. We're going to get to that in our next lesson because that's all about configuring and conceptualizing and understanding static routes. Anyway, so since we are looking at the basic configuration of a router, we need to understand some basic show commands. IP interface brief, running config, interface, show IP route, and of course ping. Again, if we're dealing with IPv4, it will just be IP. If we're dealing with IPv6, instead of being show IP route, it will be show IPv6 route. But these are basic show commands that you should become familiar with and kind of understand what they do. Show IP interface brief will give us details on the route, or will give us details on the interfaces in a brief comparison. If we're looking at route information, we want to do a show IP route, and that will give us the route information. If we want detailed interface information, that would be show IP interface. We can filter the commands with a pipe that is above enter, and we have the ability to filter it and to include one of these 4 additional commands: section, include, exclude, or begin. Where begin will be, this will display the output line from a certain point, starting with the line that matches the filtered expression. You can view output based off of section, or you can include certain things, or exclude certain things. I don't want to see a 1,000 line config. I may only want to look at the route, so I will be show run and do a pipe and include or do a section just for the route information. So we do have a lab packet tracer for you to configure some of this. So let's move on to the next section, our IP routing table. So again, the router learns information to build the routing table based off of directly connected, static routes, or dynamic route protocols, or the default routes. Some basic symbols that you need to know in the routing table. Again, L and C are directly connected routes, S is a static route, O is one of the dynamic routes, and a default route will be designated by a star. L is identified the address assigned to a router interface, where C identifies a directly connected route. L and C are directly connected routes, and they're slightly different, so know the differences between those two. So there are 3 routing table principles as described below that we need to understand. First, every router will make the decision by itself. Second, a router will have a routing table, and it may be different than the routing information in the next table. Third, routing information about a path does not provide return route information. They're talking one way only. So how do we decode the routing table? Here's an example. There are 7 key steps in understanding the routing table. Route source, how did the route get learned? Destination, that's going to be where are we sending it. 3, administrative distance. This is basically the trustworthiness. The lower the value, the better. The metric, this will identify the value assigned to reach the remote network. Lower values indicated preferred routes. So again, lower the better. Next will be the next hop. This will identify the IP address of the next router to which the packet should be forwarded. A route timestamp. This will identify how much time has passed since the route was learned. And lastly is an exit interface. How do we send the data out and to which port? And you'll notice the same 7 steps are the same whether we're talking IPv4 or IPv6. Directly connected networks, again, C or L. These are learned when the router is powered on and the interfaces are active and an IP address is assigned. Static routes are routes that were manually configured, and there are 3 primary purposes for our static routes. It provides an easier way of router table maintenance. Though this is mainly for small networks, it does not scale very well. It will use a single default route to represent a path to any network that doesn't have a more specific match. Third, it will route to and from a stub network. In this example, a stub network is a network accessed by a single route, and the router only has one neighbor. Typically, a static route is viewed as more secure because nothing can change it as it is manually configured. Here is a manually configured IPv4 and IPv6 route. You will notice at the configuration section, IP route, our remote network and subnets, and then it will be either our IP address of the next hop or the exit interface. The same general structure for our IPv6, except in IPv6 you will be using the slash notation instead of the dotted decimal notation. If we are looking at dynamically learned information, so with dynamic, each router is going to send information about the routes and the networks it has. So here, router 1 will send information to router 2, and router 2 will send information to router 1, and so forth. When they both have the same information, this will be called a converged network. So as we look at information in the routing table, you'll notice that the route information is learned via O. O is OSPF. So this is how the dynamic routing protocol, it will set the rules using OSPF to exchange that information. So notice that IPv6 routing protocols will use the link local address of the next hop router as opposed to the global unicast address. And OSPF routing configuration for IPv4 and 6 is outside the general scope of this video, because this is actually part of the 3rd course when we talk about OSPF more in depth. One thing to note also is while IPv6 will use the link local address, IPv4 will use the whatever IP address it has. They can both use exit interfaces as well, but they typically do not. The default route, again, here on R2, we will have a default route designated by zeros that will say send everything to the ISP. R1 will need to be given the route to send R2. And that is where the route origination will come into play, because basically router 2 will have to tell router 1, hey, I have a default route, here's the information. If you have a packet that's destined for a network that we're not sure of, send it to me so I can forward it on to our default route. In that case, it would be ISP. So, the structure of a routing table. Basically, IPv4 is standardized using the now obsolete class-full addressing architecture. We now use class lists. So the lookup process still uses class A, B, and C. Directly connected networks will always be indented like a child route. You'll have a main route that will be class A, B, or C, and they'll be indented sub-routes. Those are called child routes, and they will include the route source and all of the forwarding information, such as next hop, that will be useful. The class full network address of this subnet will be shown as the route entry. It's not as indented. The route is known as a parent route. So here, this is a class full address /24. Notice this will be the parent route. These are indented. These are child routes of this parent route. Same thing with this. This is the parent, these are the children. Parent, children, and so forth. What's interesting here is we have a /24. That means the first 3 octets should be identical. But here we have 2 routes that are learned that are not in that network. So that's kind of interesting. The child route will include the route source and all forwarding information, which we already know about. Class full network address of the subnet will be shown above. So here in reality, we are looking at the first 16 bits, and while we are still looking at the bits between 17 and 24, we're matching the 24th bit, and that's how we get this 2 and this. No, actually that doesn't make sense either, because 2 would not have a matching 24th bit, because that'd be the 23rd bit. So I'm not quite sure why these 2 routes are underneath this parent route, because they are not matching network bits. Alright, moving on. So the concept of a classful addressing was never designed with IPv6 in mind, so you'll notice the indentation are not the same. So an important concept was this administrative distance. You'll notice that here we have 110 out of 1. That administrative distance, or that trustworthiness, we need to understand. So first of all, AD, administrative distance, was developed so that we understand the trustworthiness of that route. The lower the number, the better. A route entry for a specific network address can only appear once it's in the routing table. However, it's possible to have multiple paths to the same destination. So how do we know which route to take? What we do is we take the most trustworthy route, and that's the route that is put into the routing table. So how do we know which is the most trustworthy? Basically, we ask 2 questions. How does the route know which source to use, and which route should it install in the routing table? And again, we look at the AD value, and that's how we decide. There are default AD values depending on the routing protocol used. If it is directly connected, it's a 0. Again, lower the number the better. So directly connected routes and static routes will always be given priority. If we're talking EIGRP, it's going to be an AD number of 90. If we're talking OSPF, it's going to be 110. If we're talking RIP, it's going to be 120. Those are the ones you really need to know for the exam. EIGRP being 90, OSPF being 110, and RIP being 120. I've seen on the Cisco exam where they'll talk about AD distances and not tell you the routing protocol or the route source. You're expected to know those 3 route sources and the appropriate AD values. Questions, concerns, please reach out. Thank you.